Hi everyone, this is the DevSecOps track, and I'm going to talk to you more about how to bring security into your DevOps. First thing first, welcome, and thanks for being here with us. I know you guys could be doing other stuff, you're all busy, but I appreciate you being here, and I have some exciting content for you. My name is Omid. I'm a client developer advocate with IBM. My expertise is in security, so I'm a security subject matter expert, SME, and my background is in automation and DevOps. Before we get into the DevSecOps part, let's talk about the software delivery lifecycle. I want to talk about Waterfall and Agile a little bit. So, in the older days, Waterfall software delivery lifecycle looked like this. So you would start with requirements, go through design, implementation, verification, and maintenance. And this was usually, I don't know, maybe a year-long process where the developers would, the architects and requirements engineers would do their job, hand it off to developers. Developers would move along, do their whole thing, and then send it off to the IT ops guys, and then the IT ops guys would ship it out. It was more like everybody would do their work, throw it off the wall, the next person would catch it and roll with it, and then the previous group was done with it. But that has changed. We've moved more to an agile methodology, where we're trying to tighten that loop of year-long, and we're trying to do everything significantly more quickly. So we have this iterative loop of doing requirements, planning, design, development, release, and monitoring how things went, so we can tighten this loop, bring it in, and move things faster. Now, to enable this, we have to bring developers and operation people together. So DevOps, as this picture shows, is really bringing development and operations together. And it means everybody is responsible for everything, development and operations. Now, this was introduced, and it works, to increase the key performance indicators, KPIs. In case you don't know, I love using acronyms, and we all do here, but I'll try to explain all this as I go along. So these KPIs that we are trying to tighten, we are trying to improve, is our release frequency. We are trying to release things faster. If you think about it, your phone, you probably get an update for an app every week, or multiple times a week. There are companies that deploy hundreds of times a day. There is no way you could have done it with the waterfall method, where you do architecture, requirements, everything just handed off the wall. So if you're releasing 100 times a day, you need this. Improved code quality, and also time to market. From the time business says, I want something, we want to get it out. Nobody has time to wait. The competitor companies are making it, so we need this fast. So really, these three KPIs forced everyone to start moving towards Agile and to start bringing everything together, and things work fine. However, there is an issue, and the issue is that the security falls behind. In the waterfall way, we had this kind of pipeline, right? The client would say, I want something, and then your strategy offering guys would say, okay, these are the requirements, the architects would do it, the builders would do it, and then in the test and deploy piece and operation part, that's where your security guys would come in, run their thorough security testing on this, take a few months. They didn't really know what the software actually does. They didn't know the code inside it. So they would kind of just run their generic testing on it, but they would do a lot of it, so it would take a lot of time. And they would eventually give you the quality assurance, say, we're good, and then you ship it out. Now, if you're deploying 100 times a day, you don't have time for this, right? What are we going to do with the security? So the problem we're facing is we need to increase the velocity. We need to kind of get this done faster. Now, to do this, the easiest way to do a solution would be to just not have security. Toss it out the window, right? Who needs security? But in reality, you shouldn't do that. The average cost of any breach is about $4 million in the US. From the time it starts happening until you figure it out and contain it and you're done, takes about 300 days. That's almost a full year. And if you're going to say, I'm just going to trust what other people do, just a little information for you. The top 10 most used containers on Docker Hub, they all have 30 or more vulnerabilities in them. So really, even if you're going to go with what somebody else thinks is okay, you're still not safe. And if you're going to put $4 million on the line, I would say that's somewhat foolish. So that takes us to a better solution, which is DevSecOps. So you're bringing developers, operations people, and your security guys all together. And another way of thinking about it is, if you're comfortable with the concept of DevOps, it's DevOps with focus on security. And all it means is that now everybody is responsible for security. It's not some guy that I throw my code over the wall, he gets it, and then he's going to do security. No, we all do security now. And so if you look at the diagram on the right, it's that little sweet spot in the middle. So, okay, how do we approach this? What's fine, DevOps, DevSecOps, but how do we approach it? Well, there are 3 overarching themes that you should think about when you're approaching this. And let's talk about those. First thing is, you need to have a principled approach. You can't just go along and see how things are turning out and go with those. You need to have principle, you need to know how you're doing this. I suggest you go to devops.org, and there is the devsecops.org. There is a DevSecOps manifesto there, and there's a link on the bottom here, where you can kind of read what should be your mindset when you're trying to do this shift, and what are things you should adhere to, what are the ways you need to think about the problem when you're trying to now bring your security into this whole tight loop. Then you should automate your trust. Previously, you would trust a group of people to automate things, to do security testing for you. Now, those people don't have time to go multiple 100 times a day over your code. So you need to automate your process of trust. You need to have something where when this thing quickly tells you yay or nay, you can trust it. You're like, okay, cool, I trust it, we're done. And last, but in my opinion, most importantly, don't do it alone. Security is one of those things where people say, oh, I'm going to go invent my own cryptography algorithm, or I'm going to go do it my way. And the biggest thing in the field of security is you always assume the attacker is smarter than you, because a lot of times you're not dealing with one person, you're dealing with a team of people, you're dealing with a state that's trying to attack you, you're dealing with a large group of very smart people who have a lot of money and they're trying to attack you. And if you're going to do it by yourself, most likely they're going to outsmart you. So go online, read about it, talk to experts, seek consultation, talk to people, don't do it alone. It's not one of those things that people can just do it alone and be done with it. So let's go over a quick summary of how we've done and where we are. So we talked about why we are moving from Waterfall to Agile. We talked about the fact that Agile is the new standard in software delivery lifecycle. We agreed that we need to embrace the DevSecOps. We can't, the previous way wouldn't work, and we don't want to be without security. It's too costly. And we also agreed that we don't want to repeat other people's mistakes, and we want to build on top of their successes. So we need to have our principle, and we need to automate our trust, and we need to work with experts on this. So now that we have agreed we need DevSecOps, the question is, what does it look like in practice? What does it mean actually to do it? Okay, we talked about all these philosophical things, we talked about how to approach it, but what does it look like in practice? And I'm glad you asked that question, because it's written huge in the middle of the screen, and I'm sure you read it. Also, you were thinking about it, right? So what you're supposed to do in this case is called, in the industry, they refer to it as shift left. If you remember the picture we talked about earlier where the security was done in the test, deploy, and operate section, we were trying to shift that to the left. We were trying to move it all the way from the beginning when the strategy and offering guys are thinking about it, from where the architect is thinking about it, where you're doing your build, when you're doing your test, your deploy. You're trying to shift the security left and not be stuck in the middle, at the very end, because we don't have time for that. By doing this, you're going to be able to better automate it because you will have thought about it from the beginning. So shift security left. It means include your security experts from the beginning. Again, it will help you automate your trust. It will help you put it in your delivery pipeline. And most importantly, it will help you pick the right tools. So using those tools, you can run things a lot more efficiently. This is a basic software delivery pipeline, right? Your developers do their development. You have a delivery pipeline. It usually does building, some testing, make some images if you're doing microservices or dealing with containers Kubernetes. And then once you've delivered it, you deploy it, and then you monitor it. So there are 4 sections: development, delivering, deployment, and monitoring. Now, if you want to secure these, we have to secure the 4 sections, right? So we do secure engineering for development. We do secure delivery pipeline for the delivery piece, secure deployment for deploy, and we do continuous monitoring for a monitoring section. So let's go over each one of these 4 and see what tools are out there and what are some concepts we need to think about. Now, this is a huge topic. It would take multiple courses to go over, not even multiple talks or hours. It would take a very long time. So I'm just scratching the surface here, but hopefully that gives you some food for thought to think about how you can build security into this or what to go look for. So let's start with secure engineering. What secure engineering means is that your application should be built to address security issues that it's going to see in the field. So you should think about it from the beginning. And some basic principles are security requirements and design. So you need to see what is your security requirements, what is your risk tolerance, and actually design your system for that. Now, this is hard. You might need to actually talk to your managers about this because security is not a functional requirement. It doesn't affect the functionality of your system. So a lot of times it's overlooked. Like you're like, oh, this works. And sure, it works. Whether security is there or not, it still works. Now, that security is what's going to cost you if you don't have it. So it's not functional, but you should think about it. Then you need to do threat modeling. This one takes time, is a little bit hard, but you need to see what the attacker would want from your system and try to model how would they approach attacking your system, where would they go, and try to harden those parts of your system. So model their behavior before they start attacking your system. And of course, have security testing, right? You need to have security tests that you have unit tests, different kinds of tests that will test your software for security. And also when you're doing code reviews, look at your coworker's code and see whether or not what they did allows for SQL injection, or whether what they did doesn't prevent some the other basic things about security. So basic stuff about secure engineering, but very important. Without it, every other thing would be useless. Next is secure delivery pipeline, and we're going to talk about this more during our hands-on section. But this is the piece where you build security tests into your pipeline. Now, there are two famous types of testing in this piece, in this section. One is called SAST, one is called DAST. SAST is static analysis security testing. DAST is dynamic analysis security testing. And what these 2 kinds of tools do, if you're familiar with testing terminology, one does black box testing, one does white box testing. So SAST looks at your code and tests it for security. DAST doesn't care about your code, treats it as something that's there, some black box, and tries to attack it from outside. Both are very important, and I'm going to compare them for you. So SAST does white box testing, looking at your code. DAST does black box testing, not caring about what is your code. SAST actually looks at your source code, which means it will actually exercise and look through all the logical parts in your code, all the logical paths in your code. It will go look at them. On the other hand, DAST, because it doesn't know your code, it can't look at all the logical possible ways, so it can't actually test for every possible way that your software would function. But as a benefit, DAST actually knows about the environment. So DAST can do environment testing, see if you have any insecurities in your environment, in the way your software works, in the way your software behaves when something goes wrong. DAST will catch those things, where SAST doesn't. And another difference between the two is SAST is earlier in the pipeline because you can run it only on the code. You don't need an environment for it. That's something that people run it very frequently, sometimes, a lot of times. Actually, developers run it themselves before they check the code in. And that gives them really quick feedback of, hey, this is bad practice, that's bad practice, this is how you should do this, that's how you should do something else. While DAST, you have to wait all the way till the end. Now, SAST, which I'll give you a couple examples of apps later about it. There are databases of common vulnerabilities that are out there and exposures where researchers have found problems that if you do something in a certain way, it allows an attacker to do this. Or if you use this version of a code, it allows some attacker to do that. Or if you use this in combination of that other thing, this dependency comes in where it gives you that. These are all known in a database, and the SAST tools actually pull in multiple databases and test your software for that for you. So really, it's a must to do, because once something is in a database, the attackers know it. And they're going to go there, they're going to actually build an attack based on it, and whoever hasn't updated the system or isn't keeping up with these, they're going to attack them all along. And you've heard a lot about people not updating their dependencies or running on some old thing, or you'll hear less about it, but some vulnerability, some style of coding being known as bad, and people doing it. So always run the SAST at the very least, because it gives you lots of information based on lots of things that researchers have done. And it is very useful for very little effort. So SAST is the must. A subcategory of it that you might hear is SCA, Software Composition Analysis. This one specifically looks at your software and how it's composed, because nowadays the software engineering is a lot of gluing different things together. We don't write everything from scratch. So it looks at the composition of your software and looks to see, okay, now that you have a dependency, how secure is that dependency? Or now that you have all these things in terms of compliance, how do their licenses play along with each other, and how does it actually, what does it mean for your softwares in terms of compliance? So that's another kind of tool that you should look at. It does composition analysis, and I mean, you wouldn't want to only look at your code. Your code is probably the minority of the amount of code that goes into your software. There's probably a lot more libraries. So this is super important. That's why I spend a lot of time on it. Please do SAST and DAST. Secure deployment. So once you've delivered your software, you're going to deploy it out, right? This step has a lot of different things based on how your environment is. So I'm going to go over some just generic concepts for you. Always stick to the principle of least privilege. Make sure you're tightening everything down and not leaving it open for the wild, and give permission to only the things that need to have permission. Do infrastructure as a code. This is a somewhat new concept where it allows you to track how your infrastructure looks like in a code. It helps you be consistent, not make mistakes, track it in the future if something goes wrong, and go back and see how things were. If you're doing threat hunting, you can see in what state you were and actually what happened at that point in time, as opposed to some guy in his memory remembering kind of sort of how things were. So that's a new concept, but it's very helpful. And finally, we have continuous monitoring. This is a broad field, and there are tools for it out there that are called security information and events management. These tools ingest information about your system. They ingest events that are happening. They ingest what's happening on your network. And then they try to aggregate it all together, look for patterns. And if they see any anomalies happening, if something is deviating from baseline, they intelligently try to mark it they try to see how severe it is, assign severity to it, and then raise alarm so you can address them. There are lots of things happening in the system, so no human has time to see all of it all at the same time. So these tools are actually very helpful if you want to be sure that that your system is working fine. And depending on your risk threshold again, you might want to have more of this or fewer, lesser amount of this. But that's an area to look at. Here are some softwares for these areas that I talked about that you can look at. We won't have time to go over all of them. Actually, we'll probably go over like one or two of them. But here are some tools. So you can go on their documentations, go on their website, or even just search the name of the tool, like search like DAST, SAST, and see what's out there for it. So with that being said, we're going to get to the most exciting part of the talk, which is the hands-on section. Let's go over the exercise of adding SAST to an existing pipeline. So just to give you some context, the pipeline we are starting with looks something like this. Is where the developer, me, is going to push some code to a repo, GitHub, and then we're going to do some testing on it, and this test will pull some packages from NPM. It's a Node.js application. Then we build a Docker container after it, and then we deploy it to IBM Cloud. Again, it's not important where you're deploying it, what packages you're using, what repo you're using, just the whole general concept. So this specific pipeline doesn't have any security in it. And like we talked about, the lowest hanging fruits, the ones that have the biggest bang for your buck, are the SaaS tools, where you just get the tool, install it, set it up, and then it will just automatically search all these common vulnerabilities and exposures databases for you and give you feedback. So let's add that in the middle of our test and build. So in this new pipeline, you see that I added a SAST block that sits between test and build. The SAST is we are going to add it in two different ways. So we're going to add a SonarQube piece to it. We're going to add a SNCC piece to it. And then those two are going to look at our software, analyze it in different ways, and give us feedback. So let's get started with what we have. Down here, we have our repo, where I already have the application running. They have already created the application. This application is being rendered here. That's a super basic application. You can, I don't know, give it a zip code, and it will give you the weather. Not all that important. And it's running through this pipeline. So it's on IBM Cloud. Again, not important. You can run it on Jenkins. You can run it on Travis, whatever you want. So we have a build piece that does our building and testing, and we have our deployment piece. Now we are going to add a segment in the middle here where it will, for us, it will do our SAS testing. So just to show you that everything works, I'm going to create a file, let's say that, and then I'm going to do a git commit, git add it, and then do a git commit to show you that we can trigger it. And then when I do git push, on the left side, you should see that the pipeline will trigger once the push is done. So now we pushed it, it went to the GitHub, and then, as you can see, the pipeline picked it up. So all we need to do is to add a block in the middle and add Snyk and SonarQube. So let's go to SonarQube first. These are some old projects that I have, and see how we're supposed to do this, right? So SonarQube, we need to either use Sonar Cloud, where you can go to SonarQube, just search for SonarQube, and then you can go to the website. They'll give you all tutorials and instructions on how to do it, how many users it has, how it works. And they have a free version for free projects that's called Sonar Cloud, and you can use it. For this demo, I am hosting my own version of it, and you can host it on IBM Cloud or wherever you want. And that will let you have your own server where you can collect all your statistics. So in my personal server that I've spun up for this demo, I'm going to create a new project, and it asks you for a name. So let's call it, I don't know, DevSecOps demo. The top part is your project key. You're going to need it so when the information comes to SonarQube, it knows what it is. And then I say setup. So now it's going to set up a project for me. It will need to give me a token. So I'll give my token a name, token for demo. This is helpful in case it gets compromised. I can revoke it and know what it is. So I'm generating a token. Click continue. You can pick the type of a project. So it's a JavaScript application. So it's in the other. I'm running Linux. And then it tells you to download a binary file, add it to your path, and then just copy, paste, and run this command. So what I'm going to do is I've already downloaded this. I'll show you how the page looks like, though. You go here, you can download it, and then you're good to go. So I'm going to run it locally to show you how it works first. So let's copy paste this, and I'm going to have to add the where I put it to path. So I'm going to make my path be main home, development, DevSecOps, digital conference, and then SonarQube, binary, and $path. So this is how you add it to your path, wherever you've exported it. And now you can literally run this command. So I'm going to right-click, press Enter. The first time you run this, it might take a little bit, because it needs to do all the scanning of everything. But after that, it will cache it, so it will make things a lot faster. So it is done scanning, and it should have sent the results up. So you won't have to do this. I did this locally to show you how it works, right? So what we just did, downloading Snyk, unzipping it, adding it to your path, and then running it with that command is what you would do in your CI/CD pipeline. So let's go take a look to see if we actually got the results. There we go, DevSecOps. So super simple program, has one bug. Only 93 lines of code, not much, and it gives you all kinds of statistics about it. Vulnerabilities, it didn't find anything based on looking at its own databases. Of course, I didn't really tell it how to scan the software, and you would have to go through the documentation to fine-tune it. But based on this basic understanding, no vulnerabilities, no security hotspots, bad coding practices, no knowledge depth, any code smells, things that are known to be bad, and no tests, of course. So no test coverage, no duplication, no nothing. So you see, it gives you a lot of information about your code and a lot of different metrics, and you can track it with time with this tool. So it's really helpful to kind of get an overview of how your software is doing in general in terms of its security and adhering to things that it needs to. OK, so let's add it in the middle of the build and deploy pipeline. So I'm going to say add stage. And in this stage, I'm going to go to, it says where you're getting what's the previous stage. So I want to get this stuff in the build folder. And I have a job. Depending on what tool you're using, your CI/CD will look different. But you basically want to run a script. And this script, I've already figured it out, so I'll copy paste it. But this is what the script is. So this is the part I copy, come here, paste. That does a wget, so it downloads it, does unzip. We don't need to do ls or pwd, and then adds it to the path. So these are the steps that you would do to set up the Sonar scanner for SonarQube. And then SonarQube gave me a command that I just typed. Let's look at it, this guy. So you would need to put this there. Now, when you do, when you do this in a proper environment, where did it go? There. OK. There we go. All right, and so we come here, and then you scroll down, and right here you can just paste that command. Now you're basically all set. This is going to download Sonar Scanner, unzip it, add it to the path, and then it's going to run it. So let's click Save, and let's just run this step to verify that it actually works. So I'm going to click Run, and that should run only wait, that's the deploy stage. You got to move it first. So we're going to move it, and then we're going to click on Run, and that should run my testing. To make it more memorable, I'm going to call this SonarQube. That way I know what it is. All right, so it's going to take a few seconds. You can look at the logs and the history, and it will basically go through and do the same exact thing that we just did in terminal. It'll just do it as a part of your CI/CD pipeline now. And then it will upload the results back up. Yep, and when it's done, we can click on the logs, and you can see that it's done all the work. And at the end, it says execution success. So at the end, it has sent the report back to SonarQube. So if I come back here, I should see the newest results that come up here. It says, so I got new code, and then no new bug has been added, no new vulnerability, everything looks good, we pass. Oh, by the way, you can set your gating property, so you can pass or fail based on different criteria, but that would be too in-depth for this talk. So we added SonarQube. Let's do something fun. I know a code that's super buggy, and I'm going to add it to our test to see how that goes, to our repo. So I'm going to copy this super buggy code from here to here. And I need to do it All right, so I copied the super buggy code. If we do git status, we should see this there. So I'm going to add it and then make a commit that says added node goat. This is a buggy code. This is a code that people use to practice their attacking skills. So it is genuinely buggy. And then we push it up. Now what we should see is that the code is going to go through the same process. Everything is going to run. And we're going to get our results at the end in SonarQube. However, it will probably be very upset. It's probably going to show us lots of vulnerabilities, lots of different things. So we're going to have to wait for it to go through the pipeline. That's fine. OK, so the SonarQube part of it is done. And it went through the SonarQube. And now if I go back to my SonarQube and refresh, it should be really angry. Yes, we failed. Our code quality went from A to C. We got 0% code coverage. We have 81 bugs now, 31 security hotspots. Everything is a mess. Of course, we knew that because this is like what this code is used for. But just to show you, see, you can go to the issues, and it will give you a list of all the issues. You can open it up. You can exactly see where it lands in your code. It gives you a suggestion how serious the problem is, what should you do about it. So it really gives you all these things for basically free. You just need to run the software. So here's an example. Here's an example of how you can do this with SonarQube and add SAST. Now, we didn't talk about dependencies here, right? So let's move and work on dependencies. For that, I'm going to teach you how to use SNCC. So let's leave this aside. I showed you how to add it to your projects, and you can add it to your projects and run it as a part of your pipeline, so you're good. Let's go to SNCC. You can go to app.sncc.io, and then you sign up, you register, and then you go to add project. So let's go to add project and say I'm trying to add a command line project. It teaches you how to run it. It says you run npm install -g snic, then you do snic auth, and you do snic monitor. That's if you're running it locally. Since we're doing this on a CI/CD pipeline, you click on down here that says configure CI, and that instead gives you the instructions on how to do it with CI/CD. So again, it says you do npm install -g snic, and then you do snic wizard and creates a .snic file. You add the .snic file, and then you do snic test. Like, it will add snic test to your npm test if you want, or you can just run snic test by hand. And the only requirement is that you have this environment variable, snic token, in your environment where snic can see it in your CI/CD pipeline. So let's go ahead and do that. I already did line 1. So let's go with line 2, and we do snic wizard. So you go in your directory, local again. We do snic wizard. And it's going to wake up. It's going to look through my stuff. And then it's going to tell me I need to run npm install first. So let's run npm install first. All right, so the npm install is done. And now you can do your snic wizard. Snic is going to go through all my dependencies and actually look to see what's happening there. Now, this is also old dependency, so there should be problems in it. Fingers crossed. Yep, there is. OK. So since this is local, let's not fix it first. Let's actually add it to our CI/CD and get the error from there, and then we'll fix it. So I'm going to say skip. It says, do you want to add it to your stuff? No, I want to run the command by hand. And it says, I'm adding a .snic file. And I'm like, OK, cool. And then we're good to go. So if I do git status, it should have added it up here. So we do a git commit, added .snic, and then we do a push. That should push it up. And now we need to add it to our pipeline. So same thing. We come here in this little stage that's here. I'm going to edit this stage, add one more piece to it for snic. It's another testing. All we need to do is run a bash script here. So let's call it snic, so I have better clarity of what's happening. And again, I have created this. But remember those things that we saw? It says run npm install, then do npm install -g snic, and then snic test. They're all here. So I'm just going to copy paste it. Where did it go? Down here. If you forget, those are these instructions. So this guy, npm install, it told us and then this, and then snick test. And now we need to create this token. So we go to environment. If you're using Jenkins, it would be a different interface, of course. Secure property, this goes here. And I've already saved my token. So I put it here, and then I click Save. So now snick is also added to my process. So if I redo this stage, I know it's running because I just pushed the code up, but that will probably skip the snick, so I'll rerun it. And then we should get the results of snick back. If everything goes correctly, it should actually break the build, because snick is going to be like, hey, your dependencies aren't good at all. It's done, and as we see, snick failed. And I expected it because we have problems in our code dependency. But just to see it, let's go to our view logs. It shows me the log of the last run where snick failed. And if you go all the way to the bottom, wait, that's showing me the, yep, that's showing SonarQube. If you go to snick, go all the way to the bottom, it tells you that it failed because it found problems that are here, high severity problems, and you would not want to deploy with high severity problems. So to fix it, it gives you a suggestion of running snick wizard, and let's actually go to snick and see it also there. So I'm going to go to my project again, and then I should see it right here, 4 minutes ago. There we go. So I have 4 high priorities, high severities, and I have 1 medium, 1 low severity. And you could go through it, read it, and see how things are, but a cool thing about this tool is that it actually helps you fix it. So if I come to my actual project and do snick wizard again, it's going to start back up and do all of its looking again. And it says, I found something. Do you want to start from scratch? I say yes. And then it says, hey, there are problems. Do you want to solve it? I'm like, sure. Upgrade this, upgrade that. And that is the, yeah, don't do that. Not fine. Now we'll do all this magic. And once it's done with its magic, we can see it has changed my dependencies file, the package.json. So let's add it. And we push it up. And that will kick off our pipeline again, during which everything should go fine. So as you saw, we got an application that had some problems. We add a SonarQube to it. And then I showed you how you can track things a long time by adding a really buggy piece of code to it and show you all the details of it. And then I showed you how you can also add snick to now look at your dependencies. And even if you build a container, it will look at your container for you. And you get this wealth of knowledge from all these libraries, from all these databases of known vulnerabilities, where you don't have to do anything. All you have to do is configure the tool and let it run every time. So that brings us to the end of the hands-on piece. I showed you guys how to add SaaS to your pipeline, and that really should give you lots of value for little effort. To recap, we learned about why we need DevSecOps. We talked about the 4 parts of it, the engineering piece of it, the delivery part of it, deployment part of it, and the monitoring part of it. And I showed you some tools that you can start using today. And then we did the whole thing together in a hands-on section. So really, all there is left to do is for you guys to go ahead, add these tools to your projects, look at other practices on how you can improve your projects, and bring DevSecOps to your projects. With that, I want to say thank you for being here and listening to me teach you about DevSecOps, and I hope you guys learned some valuable lessons.